Anyone who opened up CoinMarketCap the other night got a big surprise. There was a brand new player on the scene, and in the number 4 spot, no less. Internet Computer Protocol. But who are these guys? Get ready. Let's go. Can we just talk about their name for a second? I promise you, I am not exaggerating. When I first saw Internet Computer in the CMC list, I thought it was some kind of a joke. I was like, is it like April Fool's CMC? I think it's owned by Binance. Maybe it's like Chinese April Fool's Day. Because it's sort of like they named it like digital internet money, right? Digital internet money. It's such a generic name, I couldn't believe it was real. But that's actually not the biggest problem with this name. The biggest problem with the name Internet Computer is that the ticker symbol is ICP. And I know this Dfinity Foundation is based out of Switzerland, but in North America, especially in the US, if you've been around for the last couple decades, there is a very, very good chance you hear the letters ICP, and the only thing you can think about is the first thing that comes up, not the first thing. We'll say the most prominent thing that comes up when you Google ICP. I just Googled ICP. This is what comes up: the Insane Clown Posse, the hardcore hip hop group, or should I say horrorcore hip hop group that spawned the Juggalo movement. This is what people think of when they think of ICP. But let's talk first in broad strokes about what's actually going on with this project, right? So this project has been labeled already by some as a new entrant in the Gen 3 blockchain race, right? The same race that Cardano's in, the same race that Avalanche is in, that Algorand is in, that Ethereum 2.0 is in. And this race can be summed up by the blockchain trilemma. All right, back to my terrible, terrible drawings. Pretend like this is a triangle, right? We can see this triangle has sort of 3 big legs on it. The first one is decentralization. Decentralization, right? Another big leg is security. And the third is scalability. Scalability. Okay. So when you're trying to construct a blockchain, the big challenge has always been, how do you achieve all 3 of these at once? Because as we know from like Ripple, it's super easy to hit security and scalability with no decentralization, right? We know from ETH 1.0, it's super easy to hit decentralization without scalability or security, right? I mean, CryptoKitties broke it, and the DAO hack proved we didn't have, ultimate security. And before anybody gets all excited, yes, I know the recursive call attack on the DAO was an attack on a smart contract, not on the underlying consensus protocol. Certain blockchains, like I think Cardano and probably also Avalanche and Algorand, they were like, let's tackle every point on this triangle. Let's try to do all 3. That's the really hard thing. And whoever does all 3 actually wins the Gen 3 race. Let's do all 3 things, right? So they actually came up with interesting ways to do all 3. Like Ouroboros, like Avalanche, like the Algorand protocol. These were attempts to do all 3, right? And unsurprisingly, and ETH 2.0, all of them involve proof of stake, or in Avalanche's case, something that, has a lot of the benefits of proof of stake. Slightly different consensus protocol over there, but you get the point. So I'm going to go ahead and say when Dfinity first had their meeting, right, they were like, let's pretend like this is the head guy at Dfinity. And he's like, let's build the internet computer. He walked in the room. And he was like, okay, guys, I know we've got a huge number of engineers, which we're going to cover later. They've got a gigantic team of very high level people. I feel like I'm just going to go ahead and say this is like a CCTV footage scene of what happened when he walked in the room. He walked in the room and there were these like 100 super high level computer science guys. And he walked in the room and he was just like, hey guys, you've been in here for hours trying to solve the blockchain trilemma. Let me fix this for you. And he was just like, he's just like, let's just get rid of decentralization. We'll call it the blockchain dilemma, right? We're just going to worry about security and scalability. To hell with this decentralization thing. Let's let everybody else fight over that. Let's let everybody else fight about that. We'll just create security and scalability. We'll solve the blockchain dilemma. I know what you ICP juggalos are thinking right now. You guys are getting all heated and you're like, hey, we are certainly pursuing decentralization. How dare you impugn our crypto project like that? So here's the problem. If you go to this video, which was put out by Dfinity, right, last September, right in the video, the CEO of Dfinity, I think he calls himself the CEO. The CEO of Dfinity says, he's the one who narrates this video, I believe. He says, hey, it's a little overview of how the whole system's going to work. And he's like, hey, we're going to have these data centers and the data centers are going to have hardware. This sounds a lot like Gen 1 and Gen 2 crypto to me. This is how Gen 1 and Gen 2 blockchains work, hardware, right? He's like, we're going to have these data centers. And inside the data centers, they're going to have standardized data hardware. And I'm going to paraphrase, right? So don't give me a hard time if I don't have the exact words right, but I'm going to paraphrase exactly what I recall him saying. So he's like, we're going to have standardized data hardware in there. So this is very different than decentralized blockchains, right? Even in proof of work blockchains, you can use whatever hardware you want, right? You may not mine any blocks if your hardware is slower, but you can certainly innovate, come up with a better ASIC and mine faster than everybody else because you're more innovative. In ICP, no. Standardized data hardware is what they're describing. So you've got to have standardized data hardware. Then the data centers, and here's the big one, the data centers must apply to the network nervous system for permission to join. And they put it right here in the infographic, permission to join. This is not a permissionless blockchain. These guys don't give a damn about decentralization. This is not a decentralized blockchain. It's not even permissionless, right? He goes on to he actually says straight up, he's like, hey, the network nervous system, he's trying to make it sound familiar, right? He's like, the network nervous system plays a role like ICANN in the internet, right? This is one of the problems we're trying to solve with the internet. Everybody hates that ICANN makes it a permissioned thing, right? You can't on a permissionless basis just start, like ilovecardano.com. You got to go to ICANN and be like, yo, will you let me register ilovecardano.com? It's the same thing with the network nervous system based on that's my understanding from what I heard him say in this video. And then he goes on to say, the network nervous system also monitors the node hardware for underperformance and malbehavior and plays a role in tokenomics. I haven't even gotten deep enough to get into the fine-grained details of what role it plays in the tokenomics. But they have this like staking-esque system where you create neurons, these things called neurons, and then the neurons, can be rewarded by the network nervous system with something else, some token that can then be turned into cycles, and cycles are kind of tantamount to gas in Ethereum. To be honest with you, they lost me as soon as they told me you had to ask permission to join their blockchain. I was like, what? We're talking about a permissioned blockchain. This isn't even permissionless. And that's when I realized what was actually going on here. They're not entrants in the Gen 3 blockchain race. They're not even trying to win that race. What these guys are really trying to do, and I'm saying this as a credit to them, they're not trying to be the best Gen 3 blockchain, because that, in my mind at least, would imply that they're pursuing resolution of the blockchain trilemma, including decentralization, right? The decentralization and permissionlessness is a part of it. That's a big part of the crypto ethos. These guys aren't trying to solve that race. What they're trying to do, they're trying to fix the AWS problem. You're probably already aware of what that is, but basically, like, every company, every company that does anything that involves any kind of, computation, AWS has like captured that entire market. And in a bunch of the other videos about the internet computer, he doesn't say like, hey, we're going to be the best Gen 3 blockchain. That's not what they're all about. What they're all about is solving this problem where if you do any kind of computation online at all and you're a company, you have to do it inside the system of a proprietary vendor, right? This proprietary vendor provides you the platform for you to do that computation. But as soon as you start building on their platform, you become their captive. That's the problem these guys are actually trying to solve. And they might be doing a damn good job of that. They might be the ones who solve that problem. And I applaud their attempt to do that. But it is different than the Gen 3 blockchain race. And just to reinforce that I'm not completely against ICP and whatever its community ends up being called, I vote for Juggalos. Let's talk about a good thing about ICP. So when you go about creating a blockchain with smart contracts or canisters or whatever ICP is calling, their programmability, you could do what IOHK did. You could say, we're going to use the very best programming language, no matter how difficult it is to learn, and no matter how much it's going to turn off object-oriented programmers. Or you could be like ICP and say, yo, Solidity sucks. We're going to do better than Solidity, but we're only going to go halfway. We're not going to go to Haskell. We're gonna choose something that's going to be a lot easier for object-oriented imperative programmers. So ICP created this language called Motoko. They also have a language called Candid that has to do with public interfaces, but the main language, Motoko, is kind of interesting, right? Right here you see Motoko has been designed to be intuitive to those familiar with JavaScript, right? And if you look at it, this is not going to seem foreign to JavaScript programmers. Another interesting thing they did is they added something that Solidity does not have. And that thing is type soundness. So basically, unlike a lot of other programming languages, and Haskell does this to the nth degree, anybody who's studying Haskell right now like I am is going to know all about types. But ICP didn't go to that extent, but they did add in type soundness. So basically, this programming language, Motoko, compiles to WebAssembly. And when it compiles, it checks for type. So basically, like you tell Motoko, hey, this is going to be a program where you're going to input, letters in the alphabet, and it's going to output numbers, right? So you tell it what the types of the inputs and the outputs are going to be, the arguments and the outputs. And if you mess up in your program and you put in, letters and it outputs letters and it was expecting numbers, it's going to let you know. It's going to throw a flag at compile time. So they did some really interesting stuff that is sort of like a halfway step between Solidity, which is sort of notoriously regarded as a terrible language, and Haskell, which is notoriously regarded as a very difficult language to learn, but a good one. So there are some good things about ICP. It's just that it's not really an entrant in this Gen 3 blockchain race. And with that, I will talk to you tomorrow.